Alright, let's go through some math. Now we are almost set up very easily. Calculate the easels. I will do it for you very easily. Okay, right here. This is a very good one to work on. I will write it down for you. Design easel. What is coming in 20 years, let's say? Given by AADT times truck factor. This is number of trucks coming in a day. Number of trucks coming in a day, right? Both directions. Got it? Both directions. Number of trucks coming. Very straightforward. Times T. When I subtract this, number of trucks coming in one direction. Correct? That's approximately 50%. Everybody with me so far? Right? I'm breaking it down very simple. First, you have trucks in the entire roadway. You have NH what? 58? Whatever it is. So that both directions traffic, correct? And now I gave you that number of trucks. Now I divided it by each direction. That's 50% approximately. Then multiply by L. This is number of trucks coming in the slowest lane. Got it? Everybody with me so far? No magic here. Even I can understand this. Got it? Next one. Times 365. What does it do? What is it? Huh? 1 year. 1 year. Not 365 years. 1 year. Number of trucks coming in 1 year. Correct? Alright. Then growth factor. That's the summation that I explained to you. Remember? 100 plus 105 plus this, add them up. Correct? And that G is given by 1 plus R raised to N minus 1 over R. That is the multiplying factor that adds all the numbers. You got it? All the numbers up. Okay? So let me give an example. If R is equal to 5% and N is equal to 20, what is this G number? Can anybody calculate for me? R is in percentage, okay? R is in percentage, okay? What is the number, please? Anybody can calculate for me? 23? Give or take. What is it? Press the calculator and give me a number. Yeah. What is it? 33. So G is 33. That's it. I want to give you the significance of this 33. I want everybody's attention. What this means is, remember I started off this discussion, 100 the first year, 105 the next year, so on and so forth, 105 is to 20 year. The summation of this is 100 times 33. So you are designing for 3300 trucks. summation of all that. That's what this number 33 means. Understanding what I'm saying? So remember I explained 100, 105, 105 is 20. We're designing for all of them. And that summation will have, this was 100, that summation would have been 33. We got it? Alright, next one. Up till now you have what? Number of trucks coming in 1 year, and what is this? What is this number? Can you explain to me? Yes. What is it? 20. Yes. All total number of trucks expected in the 20 years, correct? Everybody give me some total. Very important to write it in words. Total number of trucks coming in 20 years, correct? And finally, you have to multiply it by easels per truck. That means how many easels is in each truck? That's the final number to convert it to design easels. Got it? Everybody with me so far? So the whole 90% of the calculation is about trucks, and then finally you have to convert it to easels that I explained to you. Remember how we collapse everything using EALF? Can I move on? Rest of the numbers. Any questions online? Yeah. Go ahead.
During your experiences, points, the board is not visible for us on online.
Okay. Now can you see now? Yeah.
Point.
Which one was the growth factor? Which one? So I can go to here. Design. So can you see the board now? Can you see the board now?
Yes.
Yeah. So A GT times T is number of trucks coming in a day, both directions. Okay. Times the D is the directional distribution factor that divides approximately by 50%. Now that makes it one way. Correct? L is coming in the design lane or the slow lane, not the overtaking lane. Right? There is a factor for that coming. Alright. Then times 365. That means all this while it was all daily. Now you went into 1 year. Alright. Then you apply growth factor. That is the cumulative traffic expected over the next 20 years with a given growth factor. So in this case it is 33. That means you have to multiply by 33 times. And then the final number, remember you're trying to get design easels. And one easel is a what load? Which load is easel? 18 kip single axle load. So you're collapsing everything to 18 kip single axle load using this factor, using ELF that I just explained to you earlier. We'll do some more math problems. But does that answer your question? Alright. Can you try this problem? I'm going to help you with this. Yeah. Go ahead.
But you miss truck factor.
Yeah, the truck factor is easels per truck. That is excellent. So that truck factor, the truck factor that you are saying is the easels per truck. That is excellent. So this is the truck factor. Thank you for bringing it up. Got it? That's your truck factor. That means how much easels does each truck have is your truck factor, correct? That's what that is. Does that help? Can I move on? Yeah. Yeah.
So, when the family truck will break at 4%, what will observe the period some development will take place and suddenly the urban part will be changed and this annual growth factors will suddenly rise to some let us say 6% or let us say 5%. So as we explained that number of repetitions have increased and this segment will now no longer will be able to survive for 20 years.
Yeah, can you speak away from the microphone because the voice is breaking you are asking about the growth factor. The growth factor. Go ahead. Can you repeat the question again about the?
Yes, sir. We are assuming these 4% constant growth, but what happens the way development is taking place? This growth may vary depending upon the development in that particular area. So if this portion is to let us at 5%, so number of repetitions our payment is going to survive for 20 years, that will be reduced.
Yeah, 100%.
Within 15 years the payment will pay.
Correct. So if you have a compound growth, then you can easily modify this equation to account for that. So many agencies develop their own equation for compound factors, right? So instead of having 1.45, there is a multiplying factor, and then the algorithm adjusts to account for that. So you are absolutely correct. Some of them, what they do is they do a compound factor and then fit a straight line which is much greater than a simple linear growth. Does that make sense? So I agree with you. You need to adjust your growth factor calculations depending on what you expect. So if you are expecting a compound growth, you cannot use this equation. This number could be as high as 40, 50. Does that make sense? Instead of 33. So that is correct. Does that answer?
Yes, sir.
Okay, let's go through this. Let's try this thing. I want you to use this equation. Okay, can everybody get your papers, pens, whatever you have? Rural 3 lane in each direction. Payment classification factors principle. ADT is 7315. Truck distribution is 0.7. That's your L. And growth life is here. Okay, and truck traffic is already given to you. I want you to use this equation and I will give you the truck factor. That diesel per truck I will give you. That's the only missing piece. Can everybody go to the pen and paper and calculate the design diesels, and I'm going to give you the truck factor for diesels per truck in the next one. So diesels per truck I will give you. So let's use this. ADT times TP. Can you move it? Okay, let's try this. Can you try all the way up until the diesels per truck, please? You all should get the same number. It's not a random number. Can everybody calculate all the way up to diesels per truck? Then I will tell you how to get the truck factor. Can everybody calculate that for me? Up to this 1, 2, 3, 4, 5, you should all get the same answer. All of them. I will give you the truck factor. It's also in a table in the textbook, and I'll give that to you. Can you take a photo of this so I can move off the screen for that? Anybody can take a photo of this for your head and but I will give you the truck factor. It's in a textbook, but I have to get off this slide. So if you get me up to this point, I'll be very happy. Up to this point, one single right number. Clearly understand what is given to you. Daily truck traffic is given to you. So understand each one. Do not copy, take the information, without thinking. Go by the description. So you are looking for daily truck traffic, correct? So what is given to you, you have to use that. So truck distribution design lane is the L. That's your L number. Directional distribution, you know what that is. Annual growth rate I gave you. Anybody can give me an answer at the back? Anybody have the number of trucks up to this point, up to this vertical line? I want the answer. I want total number of trucks coming in 20 years. That's what, 10 years, sorry. In this case, 10 years. Right? Does anybody have an answer? 934. Anybody second that? Third that? 934490 is up to this point. 934390. That's the number of trucks coming in 10 years, correct? Oh, it's with a growth factor. I want with the growth factor. I want a single. With the growth factor, I want up to this point. With the growth factor for 10 years. In this case, it's 10 years, right? Anybody can calculate for me? Everybody can try. Right. Anybody have an answer? I really need an answer from you guys. What is it? 1.123.
One one two 113
80. Yes. Anybody second that? 1121380. Yes, no. What is ATTT? What number is that?
71.3.
The one that's given to you. That's the truck traffic, right? I don't have any multiplication. So that number was given to you. What was that? I was just in the corner. 7105?
7315.
Yeah, whatever that number is. 7315, correct? That's given to you truck traffic. Times 0.5, times 0.7, times 365, times 1 plus 0.44, that raised to 10 minus 0.44, correct? That is 10, correct? You did that?
Right.
12. What is 12?
Those factors.
Okay, it comes to 12. Right. And that is 1121380. Does everyone get that? So, just writing those numbers.
1.2190.
19?
1.2190.
Okay. Close enough. 0. Okay. So close to around 112, 1.12 million. Give or take. Right? In that range, everybody? 602. 602. 11 million. Uh-huh. Close to 11 million? 11 million trucks? Yes. Okay. Alright, I'll trust you guys. Let's go with 11 million. Okay. Now, alright. So that's 11 million trucks. I will give you truck factor. We have to go to a table 6.310. Okay, so that's 0.38. I'm going to go to the textbook. So, table of. So, for truck factor, here. The truck factor, let's go back to them. Right here. Right here, I'm going to do it clockwise slowly. All right, that table here is given to you, it gives you the trust factor, and that happens to be 0.38. Can you do the multiplication? What do you get? 0.38 is the trust factor, and I got close to 4.3 million. You guys got the same that correct. So that's the right answer. So that if something is happening here. So for principal, can you just read this number? So your eyesight are much better than mine. So right here, that's 0.38. Right there, that's for principal, all rural interstate. Look at the problem, rural interstate, principal, all truck factor is 0.38. So now 11 point whatever you got times 0.3 is around 4.3 million. That's the final calculation. So that's what you got. ABT 0.38, 12.01, 0.5, 0.7. All right, next one. How do you calculate trust factor? That's a very, very good problem to work on. So how do you calculate, in the first problem I used the trust factor, right? Now how do I calculate the trust factor? Let's look at that. All right, let's look at this. Yeah. Okay, but right here, so trust factor. How do you calculate that? Equals per trust. I'm going to explain this to you. Okay. Let's say this is on national highways 58, right? 70. Which one? Let's look at this. These are, let's say in a given day, there are, in a given location, right? You are weighing out 200 trucks. So you are you have to weighing 200 trucks on a particular roadway. Okay? Okay? And each of these trucks are different configurations. Some are tractor trailers, some are small trucks, right? And so there will be 200 trucks that you weigh, and each of those trucks will have different configurations, correct? They can be a big truck, small truck, so on and so forth, correct? So like this, you will measure so on and so forth, correct? My point here is that there will be different configuration and different weights of different trucks on that roadway. Can everybody understand that? So in that particular span of time, I want to clearly understand, I weigh, remember not counted, I have to weigh them. I have to actually weigh them. 200 trucks I weigh. Okay? And each of those trucks will have different axle loads, correct? Correct? Some will have single axle, some will have tandem axle, some will have tridem axle. Everybody with me so far, right? So now, of all the 200 trucks, I counted of those 200 trucks, there were 7 single axles which weigh 7,000, there were 40 of them. I want to understand what this means. There were 8,000 single axles with a weight of 8,000, 150 of them. You got it? And then 12,000 single axles, 30 of them tandem, so on and so forth. So I want to clearly understand what this means. The 200 trucks I weighed had this many axles with these weights because I weighed them. You got it? Everybody with me so far? Now, once you do that, once you do this thing, the beauty of this is from then on, I have to just count the number of trucks in the future. Once I get equals per truck on that roadway, I don't have to count the axle. I have to only count trucks. Everybody with me so far. Now let's look at how do I get equals per truck. Okay. Let's look at this. Everybody understood this part at least? What does this mean? Okay. Let's look at this. Now, this is very straightforward. I have to convert everything to 18-tip single axle. Right? So there were 200 trucks weighed, right? Now let's go with this table. Single axle, 7,000 pounds, right? And let's look at number of axles were 40, right? And I have to get EALF from that table. I have to convert everything to 18-tip single axle, if you remember correctly, right? Now I have 7,000, 40, 9,000, 12,000, 30,000 tandem axles, right? And 32,000, I have what? 150, 30, 250 and 120, correct? None of them are single axle 18 tip. I have to collapse everything to 18 tip single axle, correct? Does that make sense? That means I have to use ELF that I explained to you earlier, correct? Right? Once I collapse everything to 18 tip single axle, that means those 200 trucks will have that many single axles. Can everybody understand that? Right? So this will give me 18 tip single axle equivalent, correct? For each of those. Got it? Let's go back to the table. Right here. So can anybody capture the photo of this? Or you guys got that? Can you capture this, please? I'm going to get off the screen there. And then right here. Right here. Can you guys now look at the EALF and read this table? Right? Can you guys look at the ELF and calculate what the ELF is and calculate the 18-tip single axle? Everybody got that? So for that particular load, 7,000 single axle, what is the 7,000 single axle equivalent axle load factor? 0.0196, right? Plug that in, calculate the 18-tip single axle, so on and so forth. And then you will get the total load. Can you guys do that for me? 5 minutes. You can do it 5 minutes. So if you can plug that in, 0.0196, right? 9,000, 8,000. 8,000. 8,000. So equals 9,000. 8,000 is 0.0343, correct? 12,000. 0.189. 0.189. Tandem axle, 30,000. 32 is right below. 0.658, right? And the last one I just by chance managed to capture it, 0.857, right? Okay. Right. Right. Calculate the 18-tip single axle. Very easy. When I can do this, quickly calculate, multiply, add quickly. You guys can handle this. Total summation. Total pieces I need. I don't want to write all of them. What is the total pieces? What is this number? How much? This number. Anybody? Behind in the back, feverishly typing or punching in calculator. What is it? 5.5. Which one is 548? 5.48? 40 times 0.0196. 40 times 0.0196. 0.78. Oh, thank you. That's for 0.7, right? I think you were saying total here. Our total yield is that. Okay, 0.7, right? Everybody got that? Right? That means 40 repetitions of 7,000 will cause a certain damage. The same number of repetitions will be caused by 0.7 repetition of 18 chips in the rack. Can everybody understand the concept behind that? Right? What is this number? Key. 5.145. Yeah, so just one decimal is fine. Next one. 3.1. 3.06 somebody said, right? 3.1, you are taking. Right, next one. Anybody online? Can you got it? Anybody? 5 point? But in place of 3.1, it is 5.6. This is 5.6? Yeah, multiplication. 5.6, okay. What is this one? 250 times 0.658. 1. Okay, last one. 102.8. So can everybody understand what each row means, right? So 102 repetitions of 18 chip single axles will cause the same damage as 32,000 passes of tandem axle, 120 passes of tandem axle. That's what it means, right? Now you add them all up, right? Correct? Whatever the number is, can you give me a number? 0.7. That means that 200 trucks that I weigh on an average has 276.7 ethers. That means ethers per truck is now what? Right? 1.35 give or take. 38, right? 38. Right? That's how you calculate ethers per truck. Remember the first time I gave you the number 0.38, but this is how you calculate it. The most important part is to calculate liters per truck. You have to know the truck weight, not the truck counted. Anyway. All right. So that's your first one. I did the first part. Right? I got it. The truck factor is 1.38. You all did that. You got it? Now, second one, calculate the design ethers for a 20-year design life, assuming a growth rate of 5%. Same problem as before, except that the truck factor is 1.38. And last time I gave you a 0.38 number. Everything else is the same, right? Look at the total number of vehicles counted. 15 days is 150,000. Total number of trucks counted 15 days. How much? 30,000. Pay attention to what is given to you, right? Do the same math and growth rate I was given to you, 5%. Correct? Can you now give me the design ethers? That would complete the problem fully from design, truck factor to design. Can you calculate the design ethers now based on what I have given to you here? Can I erase this? You know, that's the truck factor, right? Right here, design ethers, same thing as before. Given by A, A, B, C, E. You got to clearly understand what this means. Average daily truck traffic times B times L times G times 365 times truck factor, correct? You have everything you need to solve the problem. Okay, 6-lane road, I have to give you this. B is 0.5, correct? I will give you the L for 6-lane, I will give that to you. R is 5%, N is 20 years, correct? Truck factor is 1.38 based on what you calculated, correct? I have to give you L for a 6-lane truck. Okay? That's the only thing left, that's from the textbook. You should have everything to solve the problem. You have the number of trucks for 15 days. Just be very careful how you calculate that. So you have to convert it to average annual daily truck traffic. I will give you L. L for a 6-lane rural principal. Or more direction range from 49 to 82. So let's assume an L of 70%. So I'll give you a L of 70% because the range is 3 in each direction. It's a total of 6 lanes, right? L is 70%, 0.7. You should have everything to solve the problem. I'll go back to the problem. Calculate it for me. Not a random number. There will be one right answer or close to it. You confirm with somebody? Did you independently confirm? Anybody? What number is final answer? Design answer? One? How many million? Million. No. 16 million is the going rate here. 16 million one, 16 million two. Anybody 16 million close by? How much? 11 million. Oh my god. Your stock is dropping, guys. 11 million as a majority here. How much is the AGTT? AGTT कितना है? 30. How much? 30. 2000. Thank you. 15 days का दिया है. I have divided. Okay. Okay. 2000, right? 2000. Everybody understood that, right? It is 2000. So you have to understand. Mira, you matched it. 11 million. I forgot one fact. Okay. 11 million is the going rate. That's the right answer. Let's see. 11 million. 1.38, so we were very close, right? That's your truck factor calculation, right? That we did before. 1.38, 1.4. And what did I assume? D something. 1.35, 2, 1.4. Oh, L was my 0.8, so that was the difference. My L and the math here is 0.7. The only difference is 0.8 instead of 0.7. That's why it's 1.35, 13.5 instead of 11 million. Because I gave you an L of 70%, but I assumed an L of 80% here. That's why. Good. So 11 million is right, give or take. Good. Enough? Everybody got that? So here again, D is 0.5, L was 0.8. I gave you 7, but the number should come like this. All right. How much time we have? You good? Keep going. How much good? How much good? Again, okay. So now we are going into drainage. Yeah. So I did D times here. So D is 0.5 and L was 0.8. So 0.5 times 0.8 became 0.4. So I skipped a step. So, but I gave you a 0.7. This is the result. So you should get the same answer over. Okay, next is drainage. This is very important. Detrimental effect of water reduces strength of unbound granular material. So we are looking at drainage again. Water is a big concern. Yesterday we really hit hard on the problem with water. So looking at reducing strength of unbound granular material, it causes pumping, faulting, cracking. So and of course, poor water pressure is also an issue. It also causes durability issues as well, and swelling as well. So movement of water, again, you have simple gravity that goes to the granular material. You have capillary action that goes to fine grained soil, and then vapor pressure. So you have to look at the movement of water, which I'm sure you have learned in the hydraulics and fluid mechanics, going to Darcy's law, and looking at the coefficient of permeability times the hydraulic gradient to look at movement of water. So right here, a couple of things. You're looking at the discharge of the flow. You have to calculate how much flow is going through the water, and the more the water stays in the system, the more damage it causes. So you want the water to come in and leave as quickly as possible, and you will see that in pavement design as well. And then here are the various sources of water that you would look at. Another one is looking at bound water, looking at soil. You're looking at capillary moisture, gravity moisture, and other flow of water coming from other sources as well. So that all needs to be accounted for. Couple of other things that they allow for. Surface water is the drainage has to be significant at the top to make sure the water comes in and gets out very quickly. Permeability is a serious concern. Why is permeability a concern and not just voids? So just air voids, right, is one thing. Why is permeability a concern? What happens when you have a permeable pavement system? What makes any material permeable?
The void.
Void, but something, one more thing, more than void. What else? What is,
Porosity.
porosity. There's something about the arrangement of voids that makes the material permeable.
Interconnected.
Interconnected voids. And interconnected voids is what makes the material permeable. And when you have interconnected voids, what do you have? If you have a water go through a pavement system, you already have a void clearly connecting to the path. Correct? That acts like a crack. That disaster waiting to happen. Right? So you have created a pseudo crack without even knowing it. Permeability is a serious concern in pavements because you have interconnected voids, air pocket that is going to the depth of the structure, and that's the problem. Then permeability, for sectional pavement, these are some permeability numbers, permeability that they don't want to take, and then you want to provide logic. Surface drainage concepts for hot mix, below the hot mix asphalt layer, you want to provide drainage layer. How do you provide drainage layer? If I want to make the pavement layer more drainable, what do I need? Okay. Flow. You provide a flow. What else? What about that particular layer? What about that? If I want to make that layer drainable, what would I have to do? So I told you, make this layer pass through water. So this is the top layer, correct? So you have asphalt on top, correct? This is the asphalt, right? And this is the hot mix asphalt. If I want to make this a drainageable layer, right? Drainage layer, what properties would I give this? Give me, what would I do? Yes, fine. What characteristics would that have? Logically, what if I said, okay, make that material granular, permeable, what kind of rocks will you select? What kind of material will you select to make this permeable? Can you understand my question? You gave me the overall, I'm asking you a very specific question. Go out and collect the appropriate material to make it drainable. what we do? What properties would that material have? Anybody? Anybody online? Anybody here? They will have to have what? Large aggregates or small aggregates? Number one, large aggregates. All have the large aggregate, right? Because if I have large aggregate, right? What is the chances? You will have to have large aggregate. The chances of large aggregates having interconnected voids is very high. If the pockets are, if I take the same aggregate and I make it very small, correct? Right? Same exact aggregate, same shape, just the size is different. Okay, both are in a box of the same size. Question: which one has more voids, A or B?
The B.
B.
B. Number of all voids.
You have 50% chance of getting it.
The B.
B and both will have the same, that same one. The only difference is these are pure voids, larger air pockets. These are many voids, fewer sizes. The voids are. It's just that this will take very hard to interconnect. These are much easy to interconnect. So it's very confusing, but you will see that both of them will have the same amount of voids. But this will cause more damage in terms of structurally. So if I'm asking you for a drainage layer, you will have to have larger aggregates, possibly not angular, rounded, because you don't want them to interlock. And you will have like almost like pebble-like structures that will allow the water to go through right through the system. You will pay the price. You will have very minimal structural capacity, but the goal is different. The goal is to get the water in and water out very quickly. Does that make sense to you? But remember, these two have the same amount of voids, irrespective of what it looks. Similar amount of voids if everything else is the same. All right, what is the transverse flow? You should provide at least 1 to 2%, shoulders 3 to 6%, right? That's the longitudinal grade, of course, depends on the topography. Right here in this area, you have significant grade, right? Depending on the speed and side distance. You joint and crack sealing is needed for intercepting the drains. If you're providing drains, you want to make sure that the water doesn't leak out of the drains into the pavement. Old time tested methods, right? Provide thick HMA or PCC pavement directly over the substrate. That was very old. I want to make it thick, protect the substrate. That we did this hard yesterday as well. So you kind of, if you have water in the substrate, I don't want it to come to the surface, make it very thick. That is no longer possible. It's very expensive. Design is based on saturated substrate. That means I'm going to assume that the substrate is completely wet, completely damaged, so to speak, and I designed for that. What is the downside for that? What is the downside? What is the disadvantage of doing that? If I assume that it's completely to begin with, I don't know the water, it is good. What is the downside of that? Anybody? Downside doing that and not worry about it at all. Let's say this drainage subgrade happens once, okay, and surface stiffness PSI 2000 kW, so 4000 PSI, right? And I design that. What is going to happen? What's going to happen? If I design, what is going to happen? I design for the, it's going to be very soft. What is going to happen? What is wrong with it? What is the downside to it? You have settlement, but I have made the structure thick that I have made that irrelevant. Right? We talked about the downside of that. I make it very conservative. For 1 month, that is going to be that I've run out of money to rest of the roadway, right? Does that make sense? So it's a cost of issue, and it's expensive to do that. So you don't want to worst case in structural engineering is a critical path to fail, so on and so forth. But if you start doing it, the worst case scenario, you will run out of money very fast, right? Because it's going to be this piece is your effect of fine, right? Fine portions is deleted to prevent clogging. With this, if you want to here, I cannot have any fines. You have after that will reduce the quality of that. Effect to allow water to improve diameter person passing. That's right. Criteria. This criteria is given by 15, the number of percentage passing, the size. Diameter has 15%, 85% pass. Right, so you guys have done gradation already, right? So you want the diameter of the filter with passing divided by the diameter of the soil at least less than or equal to 5 to prevent adjacent pass. So you don't want the fine material to pass through the filter. Some other things, the filler material will be coarse enough to carry, and these are some of the matrix to do that. D15 of the filter. But again, what does D15 mean? Diameter at 15% and diameter at 50%. One for the filter and one for the soil. You can see a significant than that. And then the rest filler material as well. Couple of other points on geotextile. We have 50% passing. Number 2. Does anybody know what number 2 is? 75 microns. That's called a fine. So and average this thing should be 1 is less than D85. So some of this, every spec is different. So you have different specifications. Granular material opening, and then permeability. The permeability of the fabric should be greater than that. And so you can allow the water to go through. Then height. So you have if you're passing pipe drainage D85 of the filter and 1.2 times the slot width. Some other requirements are there. D85 of the filter to be greater than twice the maximum size. And then you have from simple hydraulics the drainage layer, which is the permeability, stroke the layer thickness, and the viscosity. I think I'm not sure if you want to do this or if you can take a break. 12:30, what time? 1:30, 12:30. Oh, then we get started with flexible payment design.